This video is going to review Module 9, Lesson 1. How do you use exponents to represent numbers? So using exponents, a number that is formed by repeated multiplication of the same factor is called a power. You can use an exponent and a base to write a power. For example, 7 to the third power, or 7 cubed, means the product of 3 sevens. So again, 7 to the third power equals 7 times 7 times 7. The base is the number that is multiplied. That's the big number. And the exponent tells how many times the base appears in the expression. So we see the exponent 3, so we have the base 1, 2, 3 times. All right, how do you read these numbers? So if we have 6 with the exponent 2, we can read it as 6 squared. The exponent 2 is always a squared. We can read it 6 to the power of 2 or 6 raised to the second power. Those are all correct ways to say that one. 7 with the exponent 3, we can call it 7 cubed, 7 to the power of 3, 7 raised to the third power. Remember, these are called powers, and so we can use that word to describe these. 9 with the exponent 4, we can say 9 to the power of 4 or 9 raised to the fourth power. Let's try. So we are going to use an exponent to write each expression. So remember, our base is going to be the number used as a factor. So in this case, our base is going to be 10, our base big number. And then our exponent is going to be how many times 10 appears in this expression. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th power. We can do the same thing with fractions. So my base is going to be that number I'm using as a factor. So this one is 7/9. You will notice when you represent fractions with an exponent, there's parentheses around it so that we know that that exponent goes with that whole part of the fraction, not just the numerator or the denominator. And then I'm going to count again how many times it's used. 1, 2, 3, 4, 5, 6, 7, 8. So 7/9 to the 8th power. The property of 0 as an exponent. So the value of any non-zero number raised to the power of 0 is 1. So anytime we have any number and we raise it to the power of 0, it's going to equal 1. It can be a decimal number. So if I had 43 hundredths to the power of 0, that would equal 1. It can be a fraction. If I had 2/3 to the power of 0, it's going to equal 1. Or just a regular whole number. So if I had 57 to the power of 0, it will equal 1. Let's try. Find the value of each power. So this means we're actually going to use either our calculator or our brains to calculate the actual number. So 10 to the third power would be 10 as a factor 3 times, 10 times 10 times 10. The value of this one is 1,000. 6/7 to the second power. So we're using 6/7 as a factor twice. Sometimes you might want to write out these fraction ones if you don't have the fraction button to use on your calculator. And so when I multiply fractions, I'm going to multiply numerators. So 6 times 6. And denominators, 7 times 7. This is 36/49. 1 1/10 to the second power. So this one you can use your calculator. Use that x squared, or x to the second power key, and you will get 1 21 hundredths. So 1/2 to the 0 power. Remember, we just read anything to the 0 power is going to equal 1. So this will equal 1. 0 9/10 to the second power. Again, I could use that calculator button, x to the second power, and this equals 81 hundredths. All right, complete the missing exponent. So on this one, I'm trying to figure out 16, so that's my value, is the same as 16 to what power? Well, in this case, if my number's not changing, my power is 1. 16 one time is going to equal 16. 125 equals 5 to what power? Okay, so I'm going to think through how many 5s will I need to get to 125. So 5 times 5, well, that's 25. And then if I do another 5, 25 times 5, that's 125. So I can look back and say that 5 to the third power, I use three fives, is 120. This time we're going to enter the base, the missing big number. So 27 equals blank to what power? So my job is to figure out the factors of 27 to see which one raised to the third power would equal 27. So 27 just has a few factors, 1, 3, 9, and 27. And so I can think through 1 to the third power. Well, that would just be 1 times 1 times 1. That's still going to equal 1. That can't be it. 3 to the third power. Let's see, 3 times 3 is 9 times 3. Oh, that does equal 27. So my missing base number is 3. 3 to the third power will get me 27. Let's find the missing base again. I'm going to start with my factors of 36. So I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 times 6. And I'm going to use that same strategy. So I'm raising something to the second power. Well, 1 times 1 is just going to equal 1, so that's not it. 2 to the second power means 2 times 2. That's 4. That's not it. 3 to the second power means 3 times 3. Well, that's not it. That's going to be 9. 4 to the second power means 4 times 4. That's 16, so that won't work. 6 times 6, that's 6 to the second power, does equal 36. So my missing base is 6. 6 to the second power will equal 6. Tim is reading a book. On Monday, he reads 3 pages. On each day after that, he reads triple the number of pages on the previous day. How many pages did Tim read on Thursday? So we're going to just map this out. And then I'll show you the way we could use exponents as well to figure this out. So on Monday, it says he read 3 pages. Okay, so we have 3. Each day after that, he reads triple the number of pages. So that means he will read his number, the 3 that he had, and triple that. Triple means times 3. So on Tuesday, he's up to 9. On Wednesday, he is now up to 9, and he's going to triple that number again. So it'll be times 3. That's 27 pages. And Thursday, this is what we need to solve for. How many pages did he read? Well, he's up to 27 pages, and he's tripling that number now, which is 81. So Tim read 81 pages. So that time I just kind of walked you through and worked everything out. But there's another way we could do this. We could use some exponents to figure this out. So we know that we're starting with that 3 pages, and we're tripling every time. And so we're going to take 3 to the 1, 2, 3, 4th power, which also would equal 81. Antonia is saving for a video game. On the first day, she saves $2 in her piggy bank. Each day after that, she doubles the number of dollars she saved on the previous day. How many dollars does she save on the 6th day? Okay, so this we're going to use our exponent to figure this out. So each day she's saving $2. That's going to be my base. And since she's doing this for 6 days, I'm going to raise 2 to the 6th power to figure out how much money she saved. So 2 to the 6th power equals $64. I could have also worked that out like I did on the previous problem and just thought, okay, here's the first day, and I know she saved $2. On the second day, she doubled that, so her $2 doubled. That would be 4. On the third day, she has $4 and she doubles that. That is 8. On the 4th day, she has $8 and she doubles that. So that's $16. On the 5th day, she has $16 and she doubles that. So that's $32. And then on the 6th day, She has $32 and she doubles that. There is our answer, 64. Doing 2 to the 6th power makes it just a little quicker for us. And so here we can see this was her initial 2 that she started with. And so we have 2. There's 1, 2, 3, 4, 5, 6 2s that we multiplied.